Welcome back to our lesson practice review, where today we are going through Chapter 2, Lesson 5 practice. To start, we're going to summarize Lesson 5 and what we should have learned from there. It really was focusing on two main aspects. First of all, when we're given something in vertex form, when we're given a quadratic in vertex form, understanding if our vertex is opening up or down and where it is transformed to, where it is shifted to see how many x-intercepts there are. So after we find that there are x-intercepts, we can solve it by just setting the equation equal to 0, right? We can set the y value or outputs equal to 0. For example, it gives you one here where it sets g of x equal to 0 and then solves it. First step is they subtract 16 from both sides. Then they divide both sides by -4. Then they take the square root of both sides. And remember that whenever you take the square root, we always get a positive or negative number for our answer. So we put that plus or minus in front of it. So the square root of 4 is plus or minus 2. Then we subtracted this 1 here to get -1 plus or minus 2 is equal to x. And then we just split that up into our two answers. -1 plus 2 is just 1. -1 minus 2 is -3. And so this tells us our two x-intercepts. So how many x-intercepts are there and how to solve for them? So for problems 1 through 3, does each function have 1, 2, or 0 x-intercepts? We're going to go ahead and start by sketching this out because really what we need to know is how is our parabola transformed. In this case, normally the vertex starts at 0, 0. This -5 here tells us that it's actually shifting 5 units to the right. So our new function, instead of looking like this first one, has now been shifted. And we see that it's only touching the x-axis one time, so it has a single x-intercept. For number 2, we are shifting the same idea. We're shifting 5 to the right and then 3 units up from there. So instead of looking like our original one, we're going 5 units to the right and 3 units up. And our parabola pointing up here is never going to cross this x-axis here. And so we say that there are 0 x-intercepts. And lastly, for number 3, we have our parabola being shifted 5 units to the right, 3 units up, but we also have this negative in the front, which means that it is being reflected. And so once we reflect it and then go 5 units to the right and 3 units up, we end up getting a parabola that points down, which means that it is going to be crossing the x-axis 2 times. So we will have 2 x-intercepts. So again, the key thing here is that this negative in the front tells us that our parabola is pointing down, which means that if our vertex is above the x-axis, we'll have 2 intercepts. For problems 4 and 5, determine the x-intercepts for each function. So these are going to be a little bit more space intensive than we're given here, so I'm going to kind of take this to the side here. But what I'm going to be doing to solve, just like in our summary, is we are going to set our output, or in this case, j of x, equal to 0 and solve for when x makes that happen. So if I were to write this to the side, we got 0 equals negative x minus 3 squared plus 4. And now I'm going to solve that for, I'm going to subtract 4 from both sides to get -4 equals negative x minus 3 squared. I'm going to divide both sides by -1 to get rid of that, which gives me positive 4 equals x minus 3 squared. Here's where I take the square root of both sides, and when I do that, I get 2 answers, positive or -2 on that left side equals x minus 3. We add 3 to both sides to get 3 plus or minus 2 equals x. And then our two answers are going to be 3 plus 2, 3 minus 2, which x is equal to 5, and x is equal to 1. So our two x-intercepts here for number 4, the way we're going to write that out is as coordinates. So 5, 0, and 1, 0, meaning when x is 5, the y value or output will be 0. And when x is 1, the output will also be 0. Okay, for number 5, same idea. We're going to set the output, or in this case, k of x equal to 0. I'm going to rewrite this problem over here. 3 times x minus 1 squared minus 15. So first step is I'm going to add 15 to both sides. Then I'm going to divide both sides by 3, which gives me 5 equals x minus 1 squared. And the next thing I'm going to do is take the square root of both sides. So in this case, we do not get a nice pretty answer because we do get 2 solutions from that plus or minus the square root of 5. But I can't take the square root of 5, so I'm just going to leave it that way. I'll add 1 to both sides to get my answer as 1 plus or minus root 5. And to write that out individually, we'll have x equals 1 plus root 5, x equals 1 minus root 5. And so even though it is a little bit, funky looking, that's okay. We're going to still put our x-intercepts over here with those as answers. We could technically, plug in the square root of 5 into a calculator and get a decimal answer, but I'd prefer having the exact answers here, which includes that square root, even though it doesn't look super pretty. Okay, for number 6, we got Jasmine claiming that this equation here has no x-intercept because the vertex of the function is above the x-axis. Is Jasmine's claim correct? And explain your thinking. So in this case here, we see 3 different numbers that are going to be transforming our original parabola shape here. The first one here is a reflection, and that's really the key to helping us answer this, because if it's going to reflect, that means our parabola is actually going to point down. And so when I go 3 units to the left and 12 units up, we get a vertex over here, which she's correct in saying that the vertex is above the x-axis. What she's incorrect about is the fact that since we have that negative number in the front, our parabola points down, which means that there's actually going to be 2 x-intercepts in that equation. For number 7, which function has x-intercepts at 2 plus root 5, 0, and 2 minus root 5, 0? There's like a lot of different ways to do this problem. If you wanted to just kind of like go at it and get started, you could just try plugging in 0 for all these y values and solving each of them until you got this as an answer. You could kind of start seeing patterns if you do that, and I'll probably start doing that for A here to kind of show you, but that would just be, 4 different problems within one. Another way you could do it is you could, since we know that these x values give us y values of 0, we could plug in these x values and see which one gives us 0 as an answer, and that would tell us. Or we can just kind of look for patterns. And so that's kind of what I want us to practice here, is to see these patterns and what happens. So I'll start by just doing if I were to say like if y is equal to 0 and solving, we'll see what happens, and that'll kind of guide us to what we think our answer should be. So first thing I would do is I would add 2 to both sides. Then I would take the square root of both sides. And when I do this, I end up getting plus or minus root 2. And in my answer, I don't have any square roots of 2. And so I already know that A is not a correct answer here. I also can kind of see that D is probably not an answer because that same process is going to happen. I'm going to subtract 2, and I'm going to take the square root. And I'm not looking for the square root of 2. I'm looking for the square root of 5. And so just knowing those first 2 steps, I can highlight the idea that I think my answer really should be C, because I'm going to add 5 to both sides, then take the square root, and that's what's going to give me plus or minus root 5 in my answer. And so just to prove that, I will go ahead and actually do C to make sure that it works here. And I'm going to add 5 to both sides. I'm going to square root both sides to get plus or minus root 5 equals x minus 2. I'm going to add 2 to both sides to get 2 plus or minus root 5. And yes, I would agree that this one works because I get 2 plus root 5 and 2 minus root 5 as my x-intercepts. So for our answer for 7, we should get C. Problems 8 and 9, change one number in each function so that it has the given x-intercepts. For number 8, it's asking for 2 x-intercepts. Right now, we are going 3 units to the right and 4 units down, and our parabola is going to be pointing down because of this negative. So when I do this, I go to the right and I go down, and right now, sorry for the lack of space, let's redo that. We're going to have something that points down and never touch the x-axis. So if I wanted it to hit the x-axis twice, I have two x-intercepts, all I have to do is change this number in the front to become positive. So if I have the function y equals 5 times x minus 3 squared minus 4, now this one would point the opposite direction, which would tell me that I would have two x-intercepts. For number 9, it asks us for one x-intercept, and so far in this problem, we're going 8 units to the right, 5 units up, and this is a positive number that's just stretching our parabola, but it's still pointing up. So when I go 8 to the right and 5 units up, I get 0 x-intercepts. The only way to get one x-intercept is when the vertex itself lands on the x-axis. And so to do that, I can't do any shifting up or down. And so to get my correct answer here, I'm going to take this equation here and I'm going to change it to not add or subtract anything. I'm changing this number right here to 0, because that way when I do this, I shift 8 units to the right and my intercept there is on the vertex. All right, for number 10, using the digits 0 to 9 each at most once, fill in each blank so that one function has no intercepts, one function has one intercept, and one function has two intercepts. Now, these problems are a little bit challenging to explain, but as I go through these, I just want you to understand that there's multiple correct answers. When I go through this, the only two things that I care about if I'm looking for the intercepts is which direction is it pointing, which I'm going to be looking at the front number here to see if it's positive or negative, and is it shifting up or down. And so I'm going to be looking at the k value here. Is it shifting up or down? And those two things are really all that matters when I'm seeing how many intercepts there are. And so the first one that I'm going to do here in the dark blue is I'm just going to plug in numbers and see if they work here, because this one here, if it's positive, it tells me it's pointing up. This +2 here doesn't necessarily change how many intercepts it has because it's just shifting that left or right. And the 3 here is telling me that since we're adding it, we are shifting it up. And so this here, 2 to the left and 3 up, is going to give me 0 x-intercepts. And so when I go through that, let's see if that works. Now, the next one here in light blue, I'm going to go ahead and say that this is 4, 5, 6. And we will see how many x-intercepts it gives me. Because this is positive, that means that it's pointing up. We're shifting 5 units to the right and 6 units down. So in this case, I go 5 to the right, 6 units down, and since it's pointing up, I see that that's giving me 2 x-intercepts. The last one here, I'm looking for 0 x-intercepts. And so in this one here, if I plug in some numbers, now this one I need to be smart about, because since I want to have a single x-intercept here, because again, I have 0 here, I have 2 here, this one needs to be 1 x-intercept. The most important thing here is that I need to recognize that this number here has to be 0. That's really the only key important number here, because if I make this 7 and 8, okay, this tells me I'm pointing down, this shifts 8 units to the left, and this does not shift up or down. So I end up getting a parabola that only touches one time since I didn't shift up or down. And so really, like, you could pretty much plug in any number you want as long as one of those k values, one of those numbers at the end here is 0. That would help tell us what's going on. All right, let's move on to our spiral review. Problems 11 through 13. We are asked to solve each equation using the method described. So really practicing our solving quadratics here. The first one we're asked to do is to factor and use the zero product property. So to factor this, I'm using my box. First term, first box, last term, last box. Middle term gets split into the other two boxes. The way I do that is I look for what multiplies to 8x squared that adds to negative 6x, which would be negative 4x and negative 2x. And so since these two things add to negative 6x, that's where I'm putting them into this box. Now I just got to figure out what goes on the outside that multiplies onto the inside, and I get my two factors. So I get x minus 2 times x minus 4 equals 0. Now, the zero product property tells us that since we're multiplying two things together, if one of them is 0, then that makes the whole thing 0. Therefore, I really need to solve this twice. What makes x minus 2 equal to 0? And what makes x minus 4 equal to 0? And when I add the numbers to the other side, I end up getting my two solutions here of x equals 2 and x equals 4. For number 12, taking the square root, okay, here I'm just going to add 16 to both sides. And then I take the square root of both sides. And remember, when I take the square root, I end up getting a positive and a negative number because 4 times 4 is 16, and negative 4 times negative 4 is also 16. Oops. And so my two solutions here are 4 and negative 4. Last problem here is going to be completing the square. So to do that, x squared minus 6x plus something, and then plus 5 minus that same something. So when I do this, I have to put that same number that goes in there. I see that half of negative 6 is negative 3. When I square that, I get 9. And so when I factor x squared minus 6x plus 9, I end up getting x minus 3 squared. And on the outside, I got plus 5 minus 9, which is negative 4. And so now I just have to solve this by adding 4 to both sides, taking the square root, which when I do that, I get two answers, plus or minus 2. Add 3 to both sides, and now I get my two answers of x equals 3 plus 2, which is 5, and x equals 3 minus 2, which is 1. Really got to kind of recap and understand how to solve quadratics here. It's going to be important in a lot of different ways of math. So that wraps up our Chapter 2, Lesson 5 practice, and we will be moving on to continue our quadratic talks in Lesson 6.